Welcome back. In today's video, we're going to go over Conti Ransomware investigation with Splunk. So today's video will be a blue team video. We're going to conduct investigation on how Conti Ransomware infiltrated a system with Microsoft Exchange Server. So as you can see, I outlined the steps. The first one was an attacker exploited several vulnerabilities in Microsoft Exchange Server. That's one. Now, in today's video, of course, we're using a recently released room from TryHackMe, the room called Conti, and it's about these several vulnerabilities that affected Microsoft Exchange Server. So an attacker exploited these vulnerabilities. Next, the next thing after the exploitation, you know that, right? They gain foothold via PowerShell. So the next step, PowerShell foothold. The third step, they migrated into another process for persistence, so that if the system reboots, they won't lose access. So anyone would migrate into another process for persistence. And the fourth step, an attacker used the PowerShell to upload and launch a web shell. The web shell will facilitate further post-exploitation operations by the attacker. That's 4. And lastly, the attacker executed commands to retrieve the ransomware. So from the web shell, they were able to retrieve the ransomware and download the ransomware into the system to encrypt all of the files. And the last thing they did is, as all of you know, they published the note that your files have been encrypted. All right, so let's see how this happened and investigate together. So this is the scenario here. The room is new actually, and it's called Conti. An Exchange server was compromised with ransomware. Use Splunk to investigate how the attackers compromised the server. So at the very beginning in task 1, you're given the ransomware node that had been left on the machine, and you're given also the credentials to log in to Splunk. Now the next task, it starts with the tasks. So what do we do now? We're gonna get started. I'm gonna switch now to my machine. So let me remove these and start over. So when you first log in, you will be given this interface. We explained how this interface works, the different parts in the Splunk series. Today I'm not going to do that. So the first thing I would like to do is to retrieve all of the data. So since we are investigating the compromise, we want to retrieve everything we have, the first thing. So we're going to type index equal asterisk to indicate that retrieve all of the data that you have, all of the data that has been gathered. So search. And we're going to see how many number of events we have got. So basically we've got 28,145 events. And also we take a look at the interesting fields. We've got several interesting fields, among which we have the computer name, the also process name, process ID, and several other interesting fields. Of course, as always with Splunk, we focus on the source type and the source. So depending on the scenario, we deselect the type of source. We have Windows login security system application, and of course we have Sysmon. Sysmon is very important in security investigations and should be installed on your IDS sensors to gather data and send it to a log aggregator such as Splunk. Okay, so now let's see the first question. Can you identify the location of the ransomware? Okay, so the first thing, we identify the dataset, and next we need to select a source. So the source type for such a question is to select the Win Event Log, Microsoft Windows Sysmon operational. We select that and we see how many events we've got, 2,664. To narrow the search even further, we specify that we're looking for exe files. Now we've got 2376. That's not enough to answer the question or to find the location of the ransomware. So we're going to take a look at the interesting fields. So we have command line, which is important. We have current directory. We're looking to find the directory of the ransomware, so that's also on the list. And we have the image of the file, the hashes. So we're going to compile all of these fields, retrieve their values using a table. So we pipe this to table, and the first thing we type is we have current directory. Next, we're gonna need the command line. We're gonna see what was the command that got executed, and also we're gonna need the image, hashes. Let's see here. So also we have parent command line, that's also important. Parent image. Also, we'd like to see the parent image. And here we have, yeah, so the last one will be the parent image. Let's see all of these fields together. Search. As you can see, we have outlined the fields in a table. Now, let's take a look and find out where that ransomware. Of course, the judgment will be the current directory. So the ransomware location will be in the directory. There will be, in order to find the ransomware, we have to look at the directory and the executable name. These would be the ideal judgment factors to find the ransomware. So here we have the current directory system 32. It would be actually sometimes it would be possible that some ransomware hides some data in the system 32, but that's unlikely to happen. So we're gonna skip all the way down. Of course, we're gonna do here. Let's do something here. So we're gonna dedup, use dedup, current directory. I want to remove the duplicate fields or duplicate values. Okay, sys32, we have administrator documents, we have sys32 as well, Mozilla Firefox, and lastly we have the Splunk. So among these directories, the only one that's weird actually is this. Take a look at this, C users, administrator documents. And the command line process that is being executed from that directory is cmd.exe. And that's the parent image. And this is the hash. Parent command line is the cmd.exe at system32, and the parent image is what was at system32 cmd.exe. So normally when you launch the command line, yes, the parent image and the parent command line would be here, but the location of the command prompt executable would not be in the user administrator. That's weird occurrence of this application. So we're gonna actually answer with this question because it is the only thing that's weird here. Yeah, we have this one as well. As you can see, we have the C Windows sys32 int srv, and we have this command attribute.exe, and then yeah, you see this one. It seems to be an application trying to launch or upload something on the web server or the Exchange server. And this is the parent command line. But this is not the ransomware, by the way. The ransomware would not execute this kind of commands. Or yeah. So basically this is actually a malicious command, of course, but it's not the answer for the question. It wouldn't be the ransomware application. So actually the answer is here. So C users administrator documents. What's the Sysmon event ID for the related file creation event? You don't need the Splunk for this question. The Sysmon event ID for file creation is 11. You can find that in the documentation of Sysmonitor. Can you find the MD5 hash of the ransomware? So that's why I selected to outline the hashes in the table here, because I want to see the hash of all of the executables. And the hash for the CMD here is this one. So you're gonna copy this and answer with this. To make sure that your answer is correct, you can just use VirusTotal to search this hash. And as you can see, the search confirms, or the results confirm the thought that this is ransomware. And specifically, it is Conti Ransomware. So now we have uncovered the first piece of the challenge. We knew what kind of ransomware that hit the machine. Take a look at the community. We see several community analysis on this file. We're not interested in this one for the time being, but we might need that later. Okay, next one. What was the file saved to multiple folder locations? Let's go back. So now we are trying to find out what is the file name saved to multiple locations. So let's reset now the command, go back, and keep only the source type as Sysmon. So since this is a file creation event, we're going to filter according to the file event. So we go to event code and we highlight 11, we click on 11. So now we got all of the file creation events, total of 104. Now to find out the file name, we're going to need to outline the results of the outline the interesting fields in the results. So we take a look here, we have the image, we need this, we're going to need also, let's see, source name, target file name. This would indicate, as you can see, the file that's being created. That's also important. We want this. So actually a total, we need the image and the target file name, the process or the executable that's saving the file, and the name of the file. So here we go back and we use table image and target file name. Okay, so as you can see, we have got several results. Of course, we're not interested in the clean manager, so we're gonna skip to the next page. We have PowerShell. We are looking to see if there are any files that have been saved by the CMD. You see now the ransomware saved several files in several locations, readme.txt, in several locations, as you can see, with the same image name. So that would be the answer for the question. What was the command the attacker used to add a new user to the compromised system? So again, here we're looking to filter by events. Normally when a user is added to the system, an event is created in Windows events. So we're going to need now to reset the command and remove all of these. We're going to change the source type to Windows Event Log Security. And specifically, we're looking to filter by event code. Let's see here. Event type, event code. So we're looking to find 4000. Let me just see here what was the code. 4701, I guess. Let's see. Where was this? The event ID for Windows user creation. Let's see here. Yeah, 4720. That was right. So 4720. So if you don't find it here, you can just type the event code, take this and use it in the filter, equal 4720. As you can see, we narrowed the results to two results, or two events too. So now it's easy to find the answer and find out what was the command that had been issued to create the user. So as you can see, we have 49 lines to look into in these events. You can definitely, of course, find the answer here, but it's more professional and practical to outline the results in a table and select interesting fields that will be shown in the table. So we have, let's see what we have here. Message, record number, source name. So we're looking to find if there is anything that has to do with the command. So I think we're gonna need to find the answer from here. So let's see. Judging by the time, we're gonna start with this one. This is the oldest one. And as you can see, this is a user account creation event, and the account name was WDA. Of course, it's not this one. This is a server's account. Next one, also a file creation event. And the file, or the user creation event, and the username was Security Ninja. The command, of course, there is no command here. So, but the first thing of the puzzle is this one, Security Ninja. Now we know the account name. So what we're gonna do here, we're gonna copy that and switch back to the original view, and here we select back the sysmonitor. Since Sysmon events log all of the commands, so we're gonna put here Security Ninja to include all of the event logs captured by Sysmon and had the Security Ninja in them. So we click enter, or we hit enter. So here we're gonna say table. Of course, we're interested in the command line. So I have them here, command line, image, parent command line. Let's see. So these are the commands that had been executed by these images. And of course, we look also at the parent command line to see the first process that executed the command or invoked the command. So we see we have here two instances or three instances of CMD. If you take a look at the corresponding command, this one, netuser/add security ninja hard to hack. That's the first one. Of course, this one would answer the question. But if you also take a look at the next one, net local group administrator security ninja, it's adding the user to administrator to elevate the privileges. And the last one is this one, which actually adds the user security ninja to the remote desktop users, so that security ninja or the attacker would be able to log in remotely using the RDP protocol. So what was the answer for the question? It's this one. Next one, the attacker migrated the process for better persistence. What's the migrated process image? And what's the original process image? That when the attacker got on the system. So here you uncover how the attacker first got into the system, right? So you have to find out what was the process used when the attacker first got into the system, and then you have to find out what was the process that were used for migration or persistence purposes. Okay, so this question actually seems to be tough, but it's not that hard. You can find the question, you can find the clue about the answer by noticing that the question is asking about an event. The event is process migration. Process migration is kind of remote thread. It's called remote thread, and we can filter all the remote thread events using Sysmonitor. You only have to find out the corresponding event ID. So for remote thread, the event ID is 8. By the way, you can get the notes by subscribing to the channel membership. Let's go back and filter for the event ID 8. And we're going to cancel all of these back and filter for event code 8. Let's see here, code, and we have 8. Okay, we have only 2 events. Again, we're going to use the table. So all of these events, actually there are only 2. They are all about create remote thread, which is process migration. Normally a process migration contains 2 fields, a source process and target process. The source process is the original process, and the target process is the process to which the migration, or to which the original process migrated. So as you can see, we have source image and we have target image. We're going to outline these in a table: source image, target image. And indeed, so the source one was PowerShell, as you can see, and the last one was unsec app, unsecurity app. It could be that. And you also have another one, unsec app into LSAS. So what does that tell you? It's telling you that PowerShell launched on the system, and then we're migrated to unsick app. Unsick app then somewhat migrated into LSAS to retrieve the hashes of the users, or the SAM hashes. So that would be the answer for the question. Just type them first with the original process and then with the next one. The attacker also retrieved the system hashes. What's the process image used for getting the system hashes? Now you can answer this question two ways. The first one is just by knowing that the process that controls or organize the hashes and the SAM database on the authentication the users, all of that is in the LSAS. If you don't know that, you can answer that by looking at these. So that's the first process, and then the next one, and lastly it migrated to LSAS. Some Googling will reveal that LSAS is the one responsible for the hashes. What's the web shell, the exploit deployed to the system? Now, it was kind of tough actually to find it, but I realized that I found the answer for this question earlier in the challenge when I found the ransomware. So let's pretend that you didn't notice that the answer was here. Now we're gonna try to find the answer just by relying on our knowledge. So we're gonna remove this and remove this. We're gonna stay with Sysmon, and now we're gonna filter the results to ASPX. Why ASPX? Because actually ASPX is the shell. If you want to deploy a web shell into an Exchange server or IIS server, you would have to do it with ASPX. That's the extension of any web shell that would be deployed into IIS server. So as you can see, you only have one event. If you take a look at the lines, you see this is the image, the file name that executed the command, and we see here the full command. Let's take a look at the command. So attribute.exe -r, specifying the destination, and the directory is program file, exchange, version 15, front end, HTTP proxy, OA, auth, and you see a weird file name. So it's the only instance of an ASPX file, and it's actually being executed by a command. We don't know what kind of command, what kind of application is that. We can Google that, but it's weird actually. And you see here the file name is not not familiar. So that would be the answer for the question. This is the web shell name. What's the command line that executed this web shell? This is the command line. And lastly, the one that I didn't know how to answer it. So another way to answer this question is without the ASPX. You can take a look at the logs created by the IIS. Let's see, where is the IIS? This is the IIS. Because IIS is the web server in a Microsoft environment. But as you can see, we got 2,864 events. So here you have the longer way to find the answer using this. And then you would go through the methods. So basically a web shell is created by a post request. So you're gonna have to select the method and go with post. So now we narrowed the results to 862. Of course, that's not enough. We're gonna have to see other fields. Let's see here, what do we have else? URL query, URL stem. So take a look at these. You can also sort the results with this one, CS URI stem. So basically table, and we would use CS URI stem. Of course, we're gonna first dedup. Take a look at this. These were the post requests on the web server. So we're gonna need to find something that's not familiar. See this one? As you can see, this is the answer for the question. And also you have, it's only ASPX file. A little investigation will show you that all web shells deployed in the Microsoft environment, specifically IIS and Exchange, are all in ASPX format. So that would be the answer for your question. Let's now jump to the last question and see why I couldn't answer this question. So what 3 CVEs did this exploit leverage? If we take a look at the hint, it's saying external research required. Now, given we knew how the challenge or knew how the attack works, and we knew also how the compromise happened, we're going to use a couple of search queries to find the answer. So the first thing is Conti Ransomware. Conti Ransomware Exchange Server PowerShell. So we have Conti Ransomware, element of the challenge. Also we have Exchange Server, the target, and PowerShell, which was the first foothold on the target. I got several results, but as you can see, all the results are pointing toward proxy shell attack. You take a look at this. For example, Conti affiliates use PowerShell proxy shell exchange ransomware exploits in ransomware attacks. An investigation into recent attacks by a Conti affiliate reveals that the attackers initially accessed targeted organizations' networks with proxy shell, an exploit of vulnerabilities. Couple of vulnerabilities in Microsoft Exchange that have been subject of multiple critical updates. Now, if you scroll down, you see how this attack would happen. Reconnaissance, indicates of compromise. So these commands were actually executed on the target. Now if you go back to Splunk and use Sysmon event, you're going to find that one of these IOCs exists here. So source type, security, Sysmon. Okay, now command line we have 100. So let's sort these. Table, command line. Now if you go to second, looking for a PowerShell one, let's do this, PowerShell. Take a look at these. See, these are the commands or the IOCs, and actually they look similar to these. Also, if you scroll down, or if you go back, check out this link. Conti Ransomware now hacking exchange servers with proxy shell exploits. Proxy shell is the name of exploit utilizing 3 chained Microsoft Exchange vulnerabilities. I tried to answer with these, but it wasn't my lucky day. Allow unauthenticated remote code execution on unpatched vulnerable servers. So that was me. I couldn't answer this question. I hope you guys have a way to find the answer. If you have got the answer, you can just help us out and put it in the comment section. So that was for today, and see you in the next video.